and then you can do it with your nails. Don't untwist it too much, so I'm going to twist it once more. Yeah, it seems okay. But before I cut the other end, I'm gonna straighten the wire using the pliers again. So I can remove the enamel and tin it. So that's what I'm going to do now. I'm going to remove the enamel the same way as we did before. Very carefully. And to save some video time, I'm not going to do it all the way in the video because I have already shown you how to remove the enamel from the wire. So here it is. The enamel is removed, and I will tin this just like before. Wait the iron to heat a bit. And I will do the same way the other end now. I cut it about a centimeter or so. And I will do the same at the other end. There the other end is done, so here is the semi-completed transformer. Now what we want to do is to identify which windings are which. If you see at the schematic, you notice these two little dots here. This means that this represents the start of the two wirings. And since this transformer is wound bifilar with the same number of turns, we don't need to worry which way around the transformer is. But we need to make sure that the beginning points of these two wirings are connected to the relevant points into the circuit. So now what we're going to do is we will identify which end wiring represents is connected to the beginning of the same wiring. So we will define the two ends of each wiring now. We know the start points, and we will identify the end points, which one represents which winding. And to do this, there's a simple way. We set up the multimeter to short circuit. So when I close the probes, when I touch the probes, there's a beep sound. And if we consider these wirings as the beginning wirings, we will identify the ends of these wirings. The multimeter probes do not do a very good contact. Okay, so this is the beginning of the first wiring, and this is the end of the first wiring. And similarly, This is the beginning of the second wiring, and this is the end of the second. Do another test just to make sure that the two windings are not short-circuited. We should not hear a beep when we touch the two wirings together, or even here. So let's do it once again. This is the beginning of the first wiring, and this is the end of the first wiring. So this is it. The transformer is ready to be connected in the splitter combiner circuit. Okay, so back in the circuit, I figured out that the F2 port in this diagram is this port here. The F1 port in this diagram is this port there. And the output in this diagram is the F3 port. So the ports seem correct here. And I have also built the circuit in a small piece of copper board of PCB, shared with another project, but let's ignore that for a bit. And this is the circuit of the splitter, and it's powered by my mini VFO. So I'm going to do some measurements now in the circuit. This is the F1 port. I haven't used the connector here. This is the F2 port, and this is the combination of the two, the F3. So I have already switched on the oscilloscope, and the first test I'm going to do is I'm going to measure the output of the mini VFO at 7 MHz alone. So this is the input, and it goes to the scope, and we can see a signal at about 7.4 MHz, and the output is 1.1 volts peak to peak at 50 ohms. We're looking at channel 2. Next, I connect directly the F1 port to the mini VFO, and the F3 port, the combination of F1 and F2, to the oscilloscope, and I leave the F2 port unconnected. So I measure the loss through the splitter of from the input port to the combined port. And as you can see, now the signal is 550 millivolts at 50 ohm. So this is exactly 6 decibels of loss, 6 dBs of loss, which is exactly as it's shown here. It says that from the input port, from one of the input ports to the combination port, you have 6 decibels of loss. Now I'm going to do the other port to see if this is true for the other port as well. Now this is it. The mini VFO is connected to the F2 port. The F1 port is left unconnected, and the output is measured again in the scope. And now we are